Well, hi there, kiddos. Today we are going to talk about solving proportions, which should not be a new topic to any of you. This is solving proportions is something that you've seen. I know you saw them in 8th grade. It's possible you saw them in 7th grade, but you've solved proportions before. We've even practiced a couple of problems that looked like proportions in the last couple weeks. So we're going to do real quick examples, 3 of them very fast, and then we'll practice homework when you come to class on Monday. So let's solve some proportions. This first one over here, this first one right here, this is a proportion because I have 2 ratios that are equal to each other. I don't know where the ratios came from. It's just given to me. Here's the proportion. We're going to solve it. To solve a proportion, we cross multiply. And when we cross multiply, we create an equation that we can solve using our opposite operation. So we're going to do that. We're going to cross multiply. So I'm going to do 2n times 8 across like that, which becomes 16n. And then I'm going to have to multiply 5 times all of this. So I have to do 5 times 3n minus 24. So I'll have to distribute so I can simplify that side. So I end up with 15n, and I will have to check that. 24 times 5 is going to be 120. So I've gotten rid of parentheses. I've now simplified. This is what my equation looks like. Well, I have n's here and n's over here. I'm going to have to get them together on the same side of the equal sign. So I'm going to subtract this 15n over here with this 16n. And when I do 16n minus 15n, I am left with 1n equals negative 120. And so the solution to this proportion is negative 120. If I plug that back into this n right here and this n right here, this ratio will now be equal to that ratio. Cross multiplication is how we solve proportions. Now this next problem is probably going to be a little different than what you're used to. It tells us that the ratio of the angles of a triangle is 2 to 3 to 4. So I have a triangle, and that gives me the ratio. We want the measure of the largest angle. Well, I'm going to draw a picture. I know that I have a triangle. So I have a triangle, and it tells me that the angles are in the ratio of 2 to 3 to 4. So that's basically like saying my angles are 2, 3, and 4. We know they can't be because those don't add up to equal 180, but they want us to find the measure of the largest angle. Well, of those 3 that I just labeled, which one is the largest angle? That's right, this 4 right here is the largest angle. I need to find out how big the biggest angle is. And so the biggest angle as it is right now is this 4. And so I know that that's the largest based on the ratios that they gave me. And just like when I'm doing a regular triangle and I'm adding up all the angles of a triangle, you know, should equal to 180. Well, these don't equal 180, but I'm still going to total them up because this is what I'm calling my angles right now. So if I do 2 plus 3, that's 5, and 5 plus 4 makes 9. So the total of the angles that I have is 9, and the biggest one is 4. If I want to find out the measure of the largest angle for real, the total of a triangle, if I added all 3 angles up for real, would be 180, and the largest one, I don't know. So that's how I would set that up. The 4 came from the 4 in the ratio is the biggest number. The 9 is from adding up all the numbers in the ratio because I would add up all the angles of the triangle, so it's in the same place as the 180 for a real triangle would equal 180. Now we cross multiply. 9 times x is 9x. 4 times 180 is 720. And so then I divide both sides by 9 so that I can get what x equals. And when I do that, I get that x equals 80 degrees. So the largest angle of that triangle, if my angles are in that ratio, 2 to 3 to 4, is going to be 80 degrees. And that's how I set that up. So let's do one last one. This is a dimensional analysis question, which you have seen dimensional analysis in science class. It's something that you have done before, but we're going to now practice it in here because it goes along with ratios and proportions very well. Dimensional analysis is a way to convert from one unit to the next without and all at once, and it's all in a nice row. So the thing we want to find out is how many seconds are in a day. So we're going to start with something really easy. All right, we're going to start with 1 day. Well, oh, actually, let's not start with a day. instead of starting with days, we're going to start with the number of seconds. It's our smallest unit of measure. And what do I know about seconds? Well, I happen to know off the top of my head that there are 60 seconds in 1 minute. Hopefully you all knew that. That's a conversion we should know. So I know there's 60 seconds in 1 minute. I also happen to know that there are 60 minutes in 1 hour. And so now what has happened is these units and these units match one another. And so if I were to multiply these two ratios together, my minutes, the units themselves, would cancel each other out. And I'm left with seconds per hour. Well, that's not what I want. I want seconds per day. So I've got to keep going. So I happen to know hours, that's the thing down here, so I want hours up here. Well, if I convert hours to days, I know that there are 24 hours in 1 day. And so now what happens is my hours and my hours cancel, so I have seconds per day when I'm done with this. So here's how it works. My units all canceled, leaving me with seconds per day. And so now I just have all these numbers to multiply together. So I have 60 times 24 all over 1 times 1 times 1, which is just 1. And when I multiply that, it will give me how many seconds there are in a day. So I'll multiply those together, and I get that there are 8,400 seconds, because those are the units left on top, in 1 day, because those are the units remaining on bottom. That's how we start dimensional analysis. You start with your smallest unit and work your way up to your largest unit. And when you are writing your ratios, you want to make sure that the denominator units of one ratio cancel out the numerator units from the ratio beside it. So the units will have to cancel. But dimensional analysis, this is something you should have seen. If you haven't, now you have. So your science teachers will be happy when you come in, and we will practice all this tomorrow. I will see you then.